Going to be learning how to graph relationships. And so the essential question that we're looking at is how can you describe a relationship when given a graph and sketch a graph given a description? So we're really looking at, this is like how we read in math. So it's interpreting paragraphs and drawing pictures for them, basically. So different things that we can look at. One is a continuous graph. And the important thing to note in a continuous graph is that the points are connected. Points are connected, okay, across the domain. So the way my teacher told me about this was with continuous graphs was that you should be, when you draw it, you can draw it without picking up your pencil. So an example of a continuous graph would be that if I just sketched a rough guy here, then a continuous graph might just kind of have like this U shape, right? And then arrows. So it goes off forever here and off forever here, but it doesn't end. It's continuous. Now, a discrete graph is a little different. A discrete graph is a collection of points. So it's a collection of points, of unconnected points, actually. Or segments. Important to note segments, because remember, segments are just like little pieces of a line. So it could have a little bit of a line on it, but those lines are not going to be connected. So it's not going to be a straight line through. It could just have like this and then maybe some dots going on for it. Okay, and this would be a discrete graph because the points are not connected. And notice how in the continuous graph, all of the points are connected, where in the discrete graph, some are connected and some are not. So the domain is another word that we really need to look at. And the domain represents the x values in a relation, in a function. So the input of a function is actually what we call it. So the numbers we put in to find out what we get, or x values. X values is the easiest to remember by because you guys know what x is. Like x is the horizontal axis, x is the first number in a point. You know this stuff. So if I gave you the example and we had, oops, why isn't it working? We had the points 1, 2, 3, 4, and 5, 6. Then the points and the domain values, we see D is going to be just the x value. So in this case, 1, 3, 5. So that is how we write the domain. I'm actually going to start making these smaller because we ain't got that much room. There we go. Nope, it's still going to be too big. Oh well, we tried. All right, so the range, if the domain is all the x values, then the range is really just the y values. So let's go ahead and do that. So domain's the input of the function, so the range is the output of a function. So if I plug in x, what do I get? Well, I get y. Y is the output. So this is the y values of the function. And again, looking at that same example, in this case, the range is the y values. So it would be 2, 4, 6. So that is the range. You have to list every single value. So in this problem, we're just going to jump to an example. And we have 3 hoses that fill 3 different water barrels. A green hose fills a water barrel at a constant rate, and a black hose is slowly opened when filling the barrel. A blue hose is completely open at the beginning and then slowly closed. We want to know which graph represents each hose. So looking at this, I'm just going to go ahead and highlight the stuff for the blue graph. Where's that highlighted? There we go. Oh, we start with the green graph. So let's start with the green graph. So for the green graph, the green hose is at a constant rate. So when we're looking at a constant rate, if I look at these graphs, this one's changing. It starts out slow and then speeds up. And then this one right here is constant. It doesn't change. It's going up at the same amount each time. And so this is actually, B is going to be represent the green hose because it grows at a constant rate. It's steadily increasing. So B equals green hose. Okay, so now that we got that straightened out, let's figure out what the black hose is. I don't even know if this black highlighter will work, but I'm actually really kind of want to try it. So black hose slowly opens and when filling the barrel. So it's starting out slow. Oh, that does work. It's cool. And then it speeds up. So we kind of talked about this on this one on graph A. It starts out slow. See how it has that low slope? And then it starts to speed up. So think about when you're filling up your glass of water, you start out slow because you want to see what the water's like, and then you speed it up. So that would represent the black hose. So that is graph A, and that is the black hose. All right, and then now we can actually do the blue hose. That's what I want to do. All right, so then I'm looking at the blue hose. It's open, completely open at the beginning, and then slowly closed. Okay, so that, I mean, the last one is A, but if you can kind of see that, it is open completely. So it's just like, oh man, it's the water bucket's filling up, and then it starts to slow down as the person turns off the hose. So C is the blue hose. All right, so then now we got to describe the water level in each bucket. So in the green hose, the water level is slowly increasing. That is what this graph tells us, right? For the black hose, again, if you look at the graph, it slowly increases and then rapidly increases. So it starts out slow. So the black hose starts out slow, then increases rapidly. And again, all I'm doing is reading the graph, right? I'm not doing anything too crazy. I'm just looking at the graph and trying to interpret what this line means. And then finally, we got to talk about that blue hose. So the blue hose does the opposite of the black hose. It starts out rapid. It starts out filling rapidly. And then slows down. Again, we can see that in this graph. It's going straight up, which it represents that being filled quickly, and then starts to level out, showing that slowing down. Okay, so the next example, we're going to sketch a graph of the situation and tell whether it's continuous or discrete, and then determine the domain and range. So in this one, again, we're going to have to read a problem and then make our graph. So a student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, they receive 10 points. So let's start out with identifying the domain and range. So domain is the input, which means that it's the independent variable. It's another word that we use to describe input, which just means that it doesn't care about anything else. Like it's something that's consistent. So in this problem, we have two variables. We have the amount of problems on the test and the amount that they answer correctly. So the amount of problems on the test is actually going to be the independent variable because there are 10 problems on the test no matter what. It doesn't care or doesn't depend on the person's score. So the domain is going to be represented by the problems on the test. So I'm going to write that down here. So remember, domain is the x value, so number problems on test. And the domain, again, is since it's the problems on test, there are 10 problems, so the domain would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to list all of the possible domain values. So if the domain is the problems on test, then the range has to be the score. And we're just going to kind of write that here for the y-axis. Okay. And notice that they receive 10 points for each problem correct. So if they answer no problems, then they have 0 points. If they answer one problem, they have 10 points. 2 is 20, and so on. It just continues increasing by 10 each time. All the way up to 100. All right, so we got the domain and range. Now let's graph this guy. So if I'm going to graph it, I got to graph each point. So I'm going to actually zoom in so you guys can see it a little bit better. So my first point is going to be at 0, 0, because if you get 0 points right, or sorry, 0 problems correct, then you're getting 0 points, right? You're not going to get, if you don't answer any problems correct, your teacher's not going to give you points. If I get 1 problem correct, then I get 10 points. If I get 2 problems correct, I get 20. 3 problems correct is 30, 40, 50, 60, 70, 80, 90, all the way up to 100. So even though I don't have numbers here, I'm going to just know that this is 1 and this is 10. And I know that's fat and doesn't look great. But basically it's 1, 2, 3, counting by 1s on the x-axis and counting by 10s on the y-axis. So now that I have my graph, remember the last part was to determine if it was a discrete or continuous. So remember, continuous is the points are connected, but in this case, the points are not connected. So the domain is actually, sorry, the graph is actually going to be discrete because the points are not connected. Graph is discrete. Okay. So let's go on to the next problem. This one, we're looking at a bathtub and it's being filled with water after 10 minutes. And there are 75 quarts of water in the tub. Then someone pulls the drain plug while the water is still running in the tub and begins to empty. The tub loses 15 quarts in 5 minutes, and then the plugs the drain and the tub fills for 6 more minutes, gaining another 45 quarts. After a 15-minute bath, the person gets out and pulls the plug. It takes 11 minutes to drain the tub. So ignore the fact that there's so many typos in there. Again, we got to determine our independent and dependent variables. So really in this problem, we're looking at time versus water height, like how much water is in the tub, right? So we need to draw a graph that paints a picture of the water level in the tub. So time in general, if you're given time, that is dependent, because again, time doesn't care about anything. Time goes on. It doesn't care if something happened. It doesn't care if there's water in the tub. Time is going to keep moving forward. So in this case, time is our independent variable, or don't input. And range has to be the water level. Now on this one, I am going to kind of label my axis a little bit, just so it makes more sense when I'm actually graphing. So I'm actually going to count by 10. So I'm going to start. So top, I'm going to have 100. And then I'm going to have, actually, since it ended up going down 2, it'll be 80. And then 60, 40, 20, 10. Was that right? No, that doesn't even work out. 10. Oh my goodness, I'm trying to figure out how I can get this level out. We just got to change the font size again. Try 9. Sorry, guys. Please bear with me. Changed it to 9. All right, so 100, 90, 80, 70. Nope, that's still not going to work. It's going too far. This is actually more like 70. 60. This would be 50. I know it's not consistent. 30. That's at 20. And then 0. So this is just to give us a rough idea of what's going on. I know it's not 100% cool, but it works out. And then time, we're going to count by 5 minutes. So I'm just going to say count by 5 minutes on here instead of writing it out loud, because obviously that didn't work out very well the first time. Okay. So let's go ahead and start graphing this bad boy. So I'm going to go ahead and use the line segment. And I'm going to have my line segment kind of correspond with each part that I'm talking about. So let's start at the very beginning. We'll start in blue because that's what I got highlighted. So it being filled with water. And then after 10 minutes, oops, don't do that. So you love it when it just pulls up random shit. So after 10 minutes, there are 75 quarts in the tub. So when I go to graph this, then after I'm going to go over to time first. So using my blue, I start at 0, right? So at 0, there's no water. And then after 10 minutes, I know that there are 75 quarts in the tub, which is right about there. And I have to kind of guess a little bit. It's between 70 and 80. All right. And then someone drains the plug. So when someone pulls the plug, it starts to lose water. And that's going to happen. It's going to lose 5 quarts in 5 minutes. 15 quarts in 5 minutes. So that's the next part. I need to represent the tub losing 15 quarts of water. So let's draw a line. Again, this time it will be black. So now it's at 75, but I lost 15 quarts of water in 5 minutes. So 75 minus 15 is 60. It's got to be right there. Yeah. Yeah, that checks out. So in 5 minutes, it's now at 16. So that's where I ended up. And then someone's like, oh crap, their tub's losing water. And so they plug it back in and fill it again for another 6 minutes. And then the 6 minutes this time, it gains 45 quarts. So again, let's highlight that so we can see it. We'll do that in red. I like red for it. We'll do that in green. So they fills for 6 more minutes, gaining 45 quarts. So this is again increasing. So it's going to go up. So 6 minutes is, oops, that's the wrong one. Yeah, sorry. 6 minutes is going to be a little bit weird because it's going to be past 5. So just a little bit past here, and it fills 45 quarts. So 6 minutes is over here on the x-axis. That's 15 plus 6, or whatever we're at now. Yeah, 15 plus 6. And it's just 21. So I'm about 21 right now. And then if I'm adding 45 to 60, I'm going to get 105, which is actually off of my chart. About right there. Okay. So that represents that being filled for 6 more minutes and gaining 45 quarts. And then somebody takes a bath. So that is actually something on their own. They take a bath for 15 minutes. And now, if you think about it, what's happening when you take a bath? Well, when you take a bath, the water level's staying the same, right? It's not changing or anything. So we actually do want to represent that time in the bath. And so in math, if you guys remember, when something's not changing, we represent that by a straight line. So we're just going to draw a straight line right now at the top here and have that go for 15 minutes. So right now we're at 21. Now I'm at 26, 31. I want to be at 46 because 21 plus 15 is 46. So this represents the person taking a bath. So it's flatlining there. And then the person gets out, they pull the plug, and the bathtub begins to lose water. And it takes 11 minutes to drain. So if it takes 11 minutes to drain the tub, then really what's that telling me? It's taking 11 minutes for the tub to become empty. So starting at 46, I feel like I did something wrong. So I'm at 21. 21 plus 15 is 36. Sorry, that's why 36. And then plus 11 is going to be 46. So after 46 minutes, the tub is empty. So let's represent that. So it takes 11 minutes to drain. So I'm going to go 1, 2 over, a little bit more. Makes 11 and drop it down all the way to 0. That represents the tub emptying out. So now this is kind of showing me, this represents the water level in the tub. I can see that it's increasing and then decreasing and then increasing again. It doesn't fill and then the tub is empty. So now it's the fun part. We get to determine the domain and range. So domain of this function is all the possible x values. So where does it start at and where does it end at? Now, we're going to just start with saying that this is a continuous graph because see how all of the lines are connected? That means that it's continuous. And the reason why I say that is because if it's a continuous graph, you actually don't need to list all of the x values and all of the y values. You just need to list from where they start to where they end. So the domain is all values from 0 to, I believe what we said was 46. And in math, you represent that with brackets. So it's 0 to, and actually we're using the wrong one, 0 to 46. Actually, sorry, that's the range. No, I am right. Sorry, brain's not working. 0 to 46. So that is the domain. It's all values between 0 and 46. And the range, likewise, well, the lowest point is 0 because that's where it started, and the highest point was 105. So the range on this graph is going to be 0 to 105. And that is our answer. All right, so now you have enough information to go ahead and start your homework. You guys have a great day.